Good day, learners. Today we'll be discussing on the topic indices, more specifically the laws governing operations on indices. Now, there are several laws of indices, and these laws are the laws we follow when we carry out operation using indices. The first law is the law of multiplication of indices. This law states that when you are multiplying two indices with similar base, you simply add the power. That is, a raised to the power of m times a raised to the power of n will be equal to a to the power of m plus n. Example, 3 raised to the power of 2 times 3 raised to the power of 5 will be equal to 3 raised to the power of 2 plus 5, which is equal to 3 raised to the power of 7. Another example, 7 raised to the power of 3 times 7 raised to the power of 11 will be equal to 7 raised to the power of 3 plus 11, which is equal to 7 raised to the power of 14. The same thing from 8 to the power of minus 3 times 8 to the power of 9 will be equals to 8 to the power of minus 3 plus 9, which is equals to 8 to the power of 6. The second law is the law of dividing indices. This law states that when you have two indices of similar base which are dividing themselves, you subtract the power. That is, a raised to the power of n divided by a raised to the power of n will be equal to a raised to the power of n minus n. Example, 5 raised to the power of 7 divided by 5 raised to the power of 3 will be equals to 5 raised to the power of 7 minus 3, which is equals to 5 raised to the power of 4. The next law is the law of power in brackets. That is, when you have any indices of the form a raised to the power of m in bracket raised to the power of n, what you do is that you multiply the power. So in this case, a raised to the power of m in bracket raised to the power of n will be equal to a raised to the power of n times n. Example, 5 raised to the power of 2 in bracket raised to the power of 3 will be equals to 5 raised to the power of 2 times 3, which is equal to 5 raised to the power of 6. The next law is the power of 0. This law states that any non-zero number raising to the power of 0 is equals to 1. A raised to the power of 0 will be equals to 1. 10 raised to the power of 0 will be equals to 1. 100 raised to the power of 0 will be equals to 1. As long as the number is not 0 and it is raising to the power of 0, the value will be equals to 1. The next law is for negative power. It states that when you have any base that is raising to a negative power, it is equal to 1 all over that base raising to that power. Example, or that is, a raised to the power of minus m will be equals to 1 all over a raised to the power of m. That is, we simply just flip it and we remove the negative sign. Example, 7 raised to the power of minus 2 will be equals to 1 all over 7 raised to the power of 2. The last law is the law of rational powers. This law states that when a base or a variable is raised to a fractional power, that the numerator of the fraction is the power and the denominator becomes the root. That is, if we have a indices of the form s is to the power of a over b, that a will be the power and b will be the root. That is, s power a over b will be equals to the b root of s raised to the power of a. Example, 4 raised to the power of 3 over 2 will be equals to the square root of 4 raised to the power of 3. And 5 raised to the power of 7 over 5 will be equals to the fifth root of 5 raised to the power of 7. Note, most of our laws only applies when our bases are similar or the bases are the same. But there is a scenario in which we can multiply numbers with different base, that's indices with different base. We can do this if the power is the same. For example, if we have an indices of the form s is to the power of a times y is to the power of a, it will be equals to sy, that is, you multiply s and y raised to the power of a. Similarly, we can also split s raised to the power of a into s to the power of a times y raised to the power of a. Example, 6 raised to the power of 2 times 3 raised to the power of 2 will be equals to 6 times 3 in bracket raised to the power of 2. Our first question is from 1991 UME, number 8. It states that what is the product of 27 over 5, 3 in bracket raised to the power minus 3, and 1 over 5 in bracket raised to the power minus 1? Now, our solution, we are going to simplify the indices for this two latter part. That's 3 raised to the power minus 3. And we know that if our index is negative, we simply flip it and remove the sign. So we are going to do that for both cases. 3 raised to the power minus 3 will become 1 all over 3 raised to the power 3. And 1 over 5 raised to the power minus 1 will become 5. Then we are left with 27 over 5 times 1 over 27 times 5. All the terms cancelled out to be equals to 1. Our next question is from UME 95. It states that evaluate 81 raised to the power of 3 over 4 minus 27 raised to the power of 1 over 3 divided by 3 times 2 raised to the power of 3. Recall 81 is equal to 9 times 9 and 9 is equal to 3 raised to the power of 2. So therefore it becomes 3 raised to the power of 2 times 3 raised to the power of 2. That is 3 raised to the power of 4. And also 27 is equal to 3 times 9. That's 3 raised to the power of 1 times 3 raised to the power of 2, which is 3 raised to the power of 3. Thus, our original equation becomes 3 raised to the power of 4 in bracket raised to the power of 3 over 4 minus 3 raised to the power of 3 raised to the power of 1 over 3 divided by 3 times 2 to the power of 3. Since we have indices in bracket, we multiply them. Our equation becomes 3 to the power of 4 times 3 over 4 minus 3 to the power of 3 times 1 over 3 divided by 3 times 2 to the power of 3. 3 to the power of 4 times 3 over 4 will give us 3 to the power of 3. 3 raised to the power of 3 times 1 over 3 will be equals to 3 to the power of 1. So our equation still breaks down to 3 to the power of 3 minus 3 to the power of 1 divided by 3 times 2 to the power of 3. 3 to the power of 3 is 27 and 3 to the power of 1 is 3. And we also know that 2 to the power of 3 is 8. So our equation simplifies to 27 minus 3 divided by 3 times 8. 27 minus 3 is 24 and 3 times 8 is also 24. So we are left with 24 divided by 24, which is equals to 1. Another example we are going to try is this question from UME 1988/8. It says that evaluate 8 to the power of 1 over 3 times 5 to the power of 2 over 3 divided by 2 over 3. Out of the numbers given, 8 can be broken further, 10 will do the same. So our equation becomes 2 to the power of 3 in bracket 1 over 3 times 5 to the power of 2 over 3 divided by 2 times 5 in bracket to the power of 2 over 3. Now we can split our denominator to become 2 raised to the power of 2 over 3 times 5 to the power of 2 over 3. Our equation becomes 2 to the power of 3 over 3 times 5 to the power of 2 over 3 divided by 2 to the power of 2 over 3 times 5 to the power of 2 over 3. When denominator moves to numerator, they gain negative power. So our equation will now be equals to 2 to the power of 1 times 2 to the power of minus 2 over 3 times 5 to the power of 2 over 3 times 5 to the power of minus 2 over 3. Recall addition of power when they are in the same base. So our equation will be equals to 2 raised to the power of 1 minus 2 over 3 times 5 to the power of 2 over 3 minus 2 over 3. Our equation will now be equals to 2 raised to the power of 3 minus 2 over 3 times 5 to the power of 0, which should be equals to 2 raised to the power of 1 over 3 times 1, which is equals to 2 raised to the power of 1 over 3, or the third root of 2. Our final example is also from UME. It said simplify the square root of 160r squared plus 71r raised to the power of 4 plus the square root of 100r raised to the power of 8. In our solution, we start solving from the most innermost part, which is the square root of 100r raised to the power of 8. Now, the square root of 100r raised to the power of 8 will be equals to, in bracket, 100r raised to the power of 8 raised to the power of 1 over 2. This will break down to 10 raised to the power of 2 over 2 r raised to the power of 8 over 2. 10 to the power of 2 over 2 is 10, and r raised to the power of 8 over 2 is equals to 4. So it becomes 10 raised to the 10 r raised to the power of 4. Now we substitute this value in our original equation. Our equation becomes the square root of 160r squared plus the square root of 71 r raised to the power of 4 plus 10 r raised to the power of 4. Now we add our r raised to the power of 4 times. That's 71 r raised to the power of 4 plus 10 r raised to the power of 4. That gives us 81 r raised to the power of 4. Our equation becomes the square root of 160 r square plus the square root of 81 r raised to the power of 4. Now if we break down 81 r raised to the power of 4, it will give us 9 r square. This further breaks our equation to the square root of 160 r square plus 9 r square. 160 r square plus 10 r square is equals to 169 r square. Our equation becomes the square root of 169 r square, which is equals to 13 r square. These are some questions for you to try your hands on. They are found in our further mathematics textbook, page number 2, and you can also get your answer in it, either our soft copy or our hard copy. Thank you.